All right, so here we are. This is marking period 3, review organic. Which formula represents a hydrocarbon? Well, first of all, you need reference tables P, Q, and R. Got to have those out. So hydrocarbons, first of all, do not have anything aside from hydrogen and carbon. So chlorine, oxygen, and that. So choice A. Which is a saturated organic compound? So saturated means all single bonds, which according to reference table Q is an alkane following the formula CnH2n plus 2. So you can go there if you want. I'm not going to scroll to that page. So double the hydrogens and add 2 compared to the carbons. So this is the same number. Hydrogens are just doubled. This is doubled and then subtract 2. This is doubled and then add 2. Choice D. What is the IUPAC name of this compound? So don't be afraid with IUPAC. This just means the formal name, the official name, not a common name. So let's first find our longest continuous parent chain. 1, 2, 3, 4, 5, 6 looks good. So that's going to be hexane, all single bonds. So it's not going to be octane. It's not going to be that one. Okay, so then we need to figure out our branches. So we've got this here, which is a methyl, and this, which is a methyl. So 2 of them is a dimethyl. And then we need to tell location. So we are going to number our carbons. 1, 2, 3, 4, 5, 6. So that would be a 4, 6 if I did it left to right. But if I went this way, it would be 1, 2, 3, 4, 5, 6. So it would be a 2, 3. Well, the answer is, oh, and also I can't count, or it's too small, it's be 4, 5. Anyways, it would have to be the lower set of numbers. You always want your locations to be the lower set of numbers. So it's going to be the 2, 3. Which is a saturated hydrocarbon? Again, we got alkanes, which is 2n plus 2 for the hydrogens. So not this one. That's just a double. 2n would be 12. That's minus 2. So choice D. Which formula represents 2-butene? So but means 4. Ene is double bond. And then the double bond is located on the 2. So all of them have 4 carbons. Double bond means you get rid of the triple. Here, that's Ene. And that's again on table Q. And so we need to figure out which has the location of the double bond after the second carbon. So this is after, part A is after the first carbon. This is after the second. So it's going to be choice B. What is the chemical name? Okay, so now we have some, what do you call it? Functional groups. So reference table R has those. We have a halide right here. So this is a halocarbon. 1, 2, 3, 4, 5 is a pentane. This is a chloropentane. But the question is, oh, and by the way, it can't be enes because those are double bonds. So then we say to ourselves, okay, what is the location? Is it the 4 or the 2? You always want the lowest number possible. So in this case, we're going 1, 2, 3, 4, 5. So off the second. The only 2 elements in alkenes and alkynes are carbon and hydrogen, hydrocarbons. Ethene would be 2 carbons, but Ene is double bond, which is an alkene, which is CnH2n. So choice A. A triple bond is found in a butene. There you go. Which general formula represents the compound CH3CH2CCH? Okay, so CH3, so that would be 1, 2, 3, 4 carbons, 1 or 3, 5, 6. So that's going to be double the carbons would be 8 minus 2. So that would be an alkyne. Cyclic hydrocarbons, benzene, toluene, looks like this. Alternating double bonds. Benzene salt. Yeah, there we go. Petroleum is a mixture of hydrocarbons. The process of separating petroleum into components based on differences is called fractional distillation. So you boil it, take some off. 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 Which element must be present in an organic compound? A. What functional group contains nitrogen and oxygen? So I'd have to go to reference table R to figure that out. And we'll see that it is an amide. An alcohol and an ester have the same molecular formula. So what would be the same? Or anything? Same functional groups? No, these are two different functional groups. So C is still in play here. And would they have the same or different properties? Well, they're going to have different properties because those functional groups allow them to be different. Hold on, my screen is falling down here. Okay, so isomers are the same number of atoms and the same kind of atoms, just in a switched up orientation. So this is C3. 1, 2, 3, 4, 5, 6, 7, 8 H's and an oxygen. So you want the same number here. So in this A, 1, 2, 3 carbons, 1, 2, 3, 4, 5, 6, 7, 8. And yeah, so it should be A because it's the same number of atoms. It's just a different orientation. You can see we've got 2 oxygens here, so that's not going to work. With C, we have only 6 hydrogens. And then with the last one, we have, not enough hydrogens. Isomers, methanol and methanal. I guess we got to draw these. Methanol. So H. Yeah, it's not going to be those because there's too many H's. Propanoic acid, prop. By the way, if you wonder how I know how to draw these, it's because I'm looking at table R, pentanoic acid and propanoic. Well, right away, different number of carbons. That's not it. I'm just going to erase a little bit of this. Did not do a great job. Here it is right here. 1 propanol and 2 propanol. Meth, eth, prop. The difference is there's 1 propanol. Okay. And then 2 propanol would just be moving this here. So yeah, the location of the alcohol. Which compound yields H plus ions as the only positive ions in aqueous solution? That would be an acid, which using reference table R, you see organic acid. Now, when we did acids and bases, HC2, H3O2. That's how we would see acetic acid, but you can also write it like D. Organic compound that has this functional group is, well, check table R, and you'll find that is an organic acid. An alcohol and an acid. So let's first of all identify. So in part A, we have an aldehyde. Use your tables. Part B, we have the acid. So let me see. So here we have the aldehyde part. Here we have the functional group acid. This is, those are the functional groups. And I can tell because they're just unique structures on our hydrocarbons. So this is a ketone in the center. And this is an alcohol. So acid and alcohol and acid would be D and B. B and So when you've got a C double bonded O at the end, it would be an aldehyde. Again, table R. What is the name of this? Meth, eth, prop, bute. So butane becomes butanone ketone, which is 2-chlorobutane. So meth, eth, prop, bute means 4 carbons, so you can't use those. And then that means that off the second carbon is a chlorine. So, and these are so close together, I apologize. In part A, the chlorine is off of the first carbon, so it can't be A. It's off the second carbon here on B. CH3COO, CH3. Those are the eyes of old Granny Esther. She looks kind of goofy. CH3, CO, O, CH3. And if you, here's her button nose. Hi, Granny. Anyways, ester. What do we got here? Okay, so we have here the amine group. So we're going to say 1, 2, 3, 4, 5. So pentanamine, or is it pentanamine? Well, amines have oxygen. So amines are just nitrogen. And again, table R. I'm not a genius. I can just use reference table R. So what is this? So we've got a carbon group. We've got an oxygen single bonded in the center. And then we've got another carbon group. This is Ether Bunny. Okay, organic reactions. So we have, looks like we have two different reactants coming together to form one product. So this is an addition. They are added together to form one. In 30, we have two bromines and then this hydrocarbon. And then we see one of the bromines came in and one of the H's came out. That's a substitution. So one of the bromines went into the game. Take me in, coach. You can tell I don't know sports. And then one of the H's came out. So the key with number 31 is you see this dot, dot, dot. This means ongoing. This means a long chain. So that is code for a polymer. We're adding together polymers, 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 and then we're going to get this really long carbon chain. Number 32, what is this? Well, I see an acid and OH, which is an alcohol. Oh, there's old Granny Esther. This is esterification, which is fermentation. Fermentation is the production of alcohol. So which produces alcohol? Well, there's an alcohol in A. No alcohol here. There's also an alcohol in C. By the way, how do I know it's alcohol? Because it's got that hydroxide group, hydroxyl. So what's the difference? Is it going to be A or is it going to be C? Well, in fermentation, not only do you give off, form an alcohol, you also give off carbon dioxide. And you need a sugar for the yeast to eat. So it is choice C. When hydrocarbons burn completely in an excess of oxygen, this is a combustion reaction. So the products of combustion are carbon dioxide and water. Draw it out if you need to. Finally, which type of reaction produces soap? Well, which one of these choices has the word soap in it? It's just mixed up. It's called a saponification reaction. Okay, if you've got any questions, please reach out. Thank you.